Here we've got an exponentials question. It's actually a hidden quadratic. Now, so you might see that it's 2 to the power of x squared minus 9, 2 to the power of x plus 8 equals 0. Now, if you can't quite see that it's a quadratic, and I'm going to do this, solve this in two ways, you might just want to consider making y equal to 2 to the power of x to begin with. So this gives you y squared minus 9y plus 8 equals 0. So the y is the 2 to the power of x. And it's 2 to the power of x squared. Now we can see we've got a quadratic equation in there. And it's quite an easy one to factorise. It's actually y minus 8 and y minus 1 equal to 0. So I've got my two y values as y equals 8 and y equals 1. And because y equals 2x, 2 to the power of x equals 8. We don't need a calculator for this. X will be 3. And 2 to the power of x equals 1. And again, I don't need a calculator. I can make it equal to 0. Now, I could have don't have to make y equal to 2x. I can just leap straight in once I've done a few of these and basically say that that's 2x minus 8 and 2x minus 1. 2 to the power of x rather, minus 1. Okay, which is what I'm going to do on the next one. So the next one, very similar, but here I haven't made it quite so explicit, but this, where I've just circled, can be split up to give me 3 to the power of x squared. So basically I can factorise this with 3 to the power of x being similar to my y in the last instruction. So I'm going to have 3 to the power of x in one bracket and 3 to the power of x in the other bracket, so that when I times those two together, I get 3 to the power of x squared. Now the two numbers have got to times together to make plus 27, and they add to give me minus 12, and these two numbers are minus 9 and minus 3. So I've got 3 to the power of x is equal to 9 from this bracket, and so x is 2, and 3 to the power of x equals 3, so x is 1.